Have a look at worksheet number 16 now that we had for homework as well. Questions 3 and 4 specifically. 3 says, an object placed 8 centimeters in front of a diverging mirror. Listen, I don't really care that it's a mirror. Right? I just care that it's diverging. Now, if it said concave, well, actually it would say convex in this case, right? Because it's a diverging mirror. If it said convex, then I would care whether it's a mirror or a lens, because that's what's going to determine whether it's converging or diverging. But if it says diverging, perfect. Okay, good enough. If it says diverging, that means we know the focal point is negative. Okay, and that's the important part for me here. Now it says the radius of curvature is 8 centimeters. What is that really telling me? Yep. Good. We know the object distance is 8.0 centimeters, and we know the focal length in this case is negative 4.0 centimeters. Half the radius, half the center of curvature, half the radius, and in this case negative because it was a diverging mirror. We want to find the magnification. So what are you going to do first? Say m is equal to, well, hi over ho doesn't make a lot of sense here, right? Di, negative di over do, that's fine, except that we don't know what di is. Sure, let's get di by using the 1 over f equation. 1 over do plus 1 over di. 1 over negative 4, and it's critical to get that negative in there. 1 over 8, 1 over di. Now by rights, you should work with fractions here, because every once in a while that rears its ugly head, but for the most part, it's pretty safe just to do our little trick here. 1 over negative 4, subtract 1 over 8, flip it over, we get negative 2.666. Danielle, what does that tell us if it's negative 2.666 for the image distance?
It's virtual.
Good. The image is virtual. Good. Now, we didn't need to know that, but okay. We already knew that it was a virtual focal point because it was a negative focal point diverging mirror. Now we know it's a virtual image as well, okay? Which, if you think to your array diagrams, it would always be a virtual image. But now let's say m is equal to negative di over do, and we're solving for m, right? Yep. So it's negative 2.6667 over do, which is 8. That gives me 0.33. Positive 0.33, which tells me that it's upright, positive, and it is smaller. Smaller, right? So we have a smaller, upright virtual image. If you think back to your array diagrams, every time you have a diverging lens or mirror, it's smaller, upright, and virtual. So that's a nice little check for you, right? Yeah?
So just to be clear, if m is negative, it's inverted.
Yeah, if m is negative, assuming the object is right side up, if m is negative, then the image is inverted. Okay. 4, a story uses a diverging mirror with a, there we go again with that diverging. That's okay. Like, it's not a big deal. You just got to catch the fact that it's diverging, right? Mirror, lens, whatever. The focal point is negative. Radius of curvature of 1 meter to keep an eye on the shoplifters. How tall would the image of a 1.8 meter tall man be if he were standing 5 meters in front of the mirror? Okay, what do we got here? What does this radius thing matter? We just went through this in question number 3, right? Where does the radius come into play? That's 2f, right? So f is going to be negative 0.500 meters, right? Negative because it's a negative focal point because it's a diverging mirror, and it's half the radius. Something is 1.8 meters. What's that? That's HO, yeah, and it's positive because we're going to assume the man's standing on his feet, not on his head in the store. Yeah, listen, I never, ever want to hear of any of you shoplifting, okay? But I'm going to just give you a second piece of advice beyond don't shoplift. If you were to do something that was, maybe a little wrong, Don't stand on your head while you do it, okay? Because you're just going to draw attention to yourself. It's way harder to get away with it and way harder to like run away if they catch you, too, if you're standing on your head. So HO is, we're going to assume positive, 1.80. What's the 5.00 meters thing? That's going to be DO. That's where he's standing. And what are we looking for here? The image height, right? HI. Any ideas? Yep.
Use the 1F equals 1 over D equals 1 DI to get I.
Okay. So let's get DI here. 1 over negative 0.50 equals 1 over 5 plus 1 over DI. Get DI. Now, I absolutely think that's going to be helpful to me, but if it's not, like, so what? Like, there's only two equations, so if I try one and it's not helpful to me, then, oh well, I'll try the other one. DI works out to be negative 0.4545 meters here. Make sure you can get that. If you can't, then let me know. I'll help you with that. Now let's say HI over HO equals negative DI over DO. That's the magnification equation, right? Negative 0.4545 divided by 5. You divide those two numbers, multiply it by 1.8, and HI works out to be 0.164 meters. So this image, the image of this guy would be larger, smaller, same size? Smaller, clearly smaller, right? Right side up, upside down? Right side up, real or virtual? Virtual based on the negative image distance. If you think back to your ray diagrams, whenever you have a diverging mirror or lens, the image is right side up, smaller, and virtual. So again, you know, I've told you right from the beginning, we don't need to necessarily memorize the ray diagrams. Sometimes we've seen lots of times where they can be helpful. Okay? Just about every time they can be helpful in like kind of double checking an answer, right? My attributes mathematically are consistent with my attributes that I come up with from my ray diagrams, probably going to be right on the question.